Hey everyone, this is Kaylee. Today I'm going to be talking about section 2.31, Area and Properties of Polygons, on pages 101 to 111 from the Math Resource Guide. Here's some background information on convex polygons. A convex polygon is known as a nice polygon, where each interior angle measures less than 180 degrees. The sum of angles in a convex polygon can be found by using the following formula. Open parentheses, n minus 2, close parentheses, times 180 degrees, where n represents the polygon's number of sides. And down below, I made sure to insert some pictures of the upcoming polygons we're going to be seeing in this math lecture. So here we have some triangles, some quadrilaterals, a hexagon, a pentagon, and some more triangles. So here are the properties of triangles. All polygons are made out of triangles. That is really important. And a singular triangle has a sum of 180 degrees. The way you can find the sum of angles in a triangle is by determining the number of sides this polygon, aka triangle, has. And the way you can do that is by taking out the root word tri, which means 3, or just counting the sides that this polygon has. So now that we've established that there are 3 sides to this polygon, which means that n equals 3, we can now plug this into our convex polygon formula and solve. So 180, open parentheses, 3 minus 2, close parentheses, equals 180 times 1, which is 180 degrees. So the sum of angles for a triangle is 180 degrees. Quadrilaterals. So as I said earlier, all polygons are made out of triangles, and a single quadrilateral has a sum of 360 degrees. And the way you can find this is by first determining the number of sides this quadrilateral will have, and you can either do that by taking out the root word quad, which means 4, or just counting the sides. So there are 4 sides, which means that n equals 4, and I plug that into the equation, and that would be 180, open parentheses, 4 minus 2, close parentheses, equals 180 times 2, which is 360 degrees. And then here are hexagons. Here you guys are going to fill in the blanks. They're all in pink. So here you would put the sum of blank degrees, and then the root word means the number, and then so there are number sides, and then n equals the number, and then the number equals the product of that here, and then here would be your sum of. So if you need some more time, make sure to pause the video and press play when you're ready. And I'm going to be showing the answer in 3, 2, 1. Woo! Congratulations! I hope you got this. If not, I'll walk you through the steps on how you would get this. So a hexagon, you would take out the root word hexa, or just count the sides, and that would mean that there are 6 sides, therefore n equals 6. And so you just plug in 6 into the equation. So 180, open parentheses, 6 minus 2, close parentheses, equals 180 times 4, which is 720 degrees, which is the sum of angles for a hexagon. And here's an example which I took straight from the combo quiz. It's problem number 6, and it states the sum of angles in a 12-sided polygon is. And so here you would use the convex polygon formula to solve, and make sure to pause the video so you have enough time to solve. And I will be showing the answer in 3, 2, 1. Yay! So I'm going to walk you through how to solve for this equation. And so, as I mentioned earlier, you would use the convex polygon formula, which is parentheses open and minus 2 parentheses closed times 180 degrees, and you would plug in 12 into n because that's the number of sides there are in this polygon. So it would turn into parentheses open, 12 minus 2 parentheses closed times 180 degrees, which is the same as 10 times 180 degrees, which is 1,800 degrees, and this would be the sum of angles for the 12-sided polygon. And here's some background information on concave polygons. So these are the bad polygons, whereas the convex polygons were the nice, good polygons. And these concave polygons have one or more interior angles which measure more than 180 degrees. And the sum of angles in a concave polygon formula is as shown. It's the same as a convex polygon formula. However, concave polygons, as you can see in the figures below, they kind of have like a caved in vertex side sort of thing going on, and it kind of switches up how you would get to the convex polygon sum of angles formula. Therefore, n now represents n minus 1, which is the polygon's number of sides minus 1. And so when you simplify this in the equation, n minus 1 minus 2 turns into n minus 3. And so you would have 3 parentheses open, n minus 3, parentheses close, times 180 degrees, parentheses close, plus 180 degrees, parentheses close. And that is just the same as n minus, parentheses open, n minus 2, parentheses close, times 180 degrees. So whether it's convex or concave, the sum of angles in a polygon formula is the same. And so here is the formula for the number of diagonals in a convex polygon. It is n times, parentheses open, n minus 3, parentheses close, over 2. And here are the polygons. This has 4 sides. It's a rectangle. And here it is. And so here are the number of diagonals it has. Here's the pentagon. Here's the number of diagonals it has. Here's the hexagon, and so forth. And we're going to solve right now together the number of diagonals in this rectangular polygon. And so based on the information given in the figure, or just, looking at an imaginary rectangle, we know that it has 4 sides. Therefore, we're going to plug in 4 into n. So that is going to be 4 times, parentheses open, 4 minus 3, parentheses close, over 2, which will be 4 times 1 over 2, which is 4 over 2, and once that's simplified, it is 2. Therefore, that is how you solve for the number of diagonals in this rectangular polygon. And I also want to mention that diagonals are technically a line segment which connect two vertices. And so here's 1, and here's 2. And I also want to mention that diagonals, the number of diagonals in a convex polygon, they never end up being a fraction number, and they're always even numbers. And then here's the formula for the number of diagonals in a convex polygon. Once again, but we are going to try a 100-sided polygon this time. And this formula is usually most efficient when using big numbered sided polygons like 100, because for the rectangle you could automatically tell how many lines it had, but so to say with this pentagon here there are so many lines it'll take a long time to count, whereas solving the number of diagonals with this formula is more efficient. And so here I want you to try and solve this equation for this 100-sided polygon, and I will be walking you through the steps after I show the equation. So press pause if you haven't solved it already. 3, 2, 1. Woo! Okay, so we're going to plug in 100 into n in the convex polygon number of diagonals formula. And so that's going to be 100 open parentheses, 100 minus 3, parentheses closed, over 2, which is equal to 100 times 97 over 2, and that will turn into 9,700 over 2, which is 4,850, and that is the number of diagonals which will be in a 100-sided polygon. And here is an example I've taken straight from the combo quiz. This is problem number 2, and this problem states, a 20-sided convex polygon has blank diagonals. And so what you wanted to do was plug in 20 into the equation. So it would have been 20 times open parentheses 20 minus 3, parentheses closed, over 2, which is equal to 20 times 17 over 2, which would have been 340 divided by 2, which is 170. And this is a number of diagonals which would have been present in a 20-sided convex polygon. And here is the area of polygons, hexagon. And a regular polygon is a polygon which is completely symmetrical, it's equilateral and equiangular. It basically means that all of the sides are the same length and all of the angles are the same measure. And I also want to mention that area of polygons can only be applied to regular polygons. And here we're going to solve for this hexagon pictured on the bottom right, figure 2-55. And this hexagon has 6 sides, and so we're going to use the convex polygon equation to start off. So open parentheses 6 minus 2, close parentheses, times 180 degrees equals 720 degrees. And I want to mention that each of these interior angles, so 1, 2, 3, 4, 5, 6, each of them measures 120 degrees. And because of that, we're going to want to cut up each of these triangles into 2 so they can turn into 30, 60, 90 degree triangles like this. So we can use these to solve for the area. When finding the area for a triangle, you want to use the area equation. So this would be 1/2 times base times height. And in this case, base would be 6 due to the side length being 6, the original side length. And then h, height, would be 3 square root of 3. And this is because when you cut the base into a half, you get 3. So 6 divided by 2 is 3. And therefore, this is just half of it. So it's 3 right here. A equals 3. And then you plug in 3 into this a. So it's 3 square root of 3. And so when you multiply this, half of 6 is 3. And then 3 times 3 square root of 3 is 9 square root of 3. And then because you have 6 triangles here, you multiply your result, 9 square root of 3 by 6, and you get 54 square root of 3. And this is the area of a hexagon with a side length of 6. Here is the formula to find the area of polygons. It's in the math resource guide, so I just took a screenshot of it. And it is n times s squared over 4 times tangent, open parentheses again, n minus 2, close parentheses, times 180 degrees over 2n, close parentheses. And in this equation, n equals the polygon's number of sides, and s equals the side length given. And tangent is just a button on the calculator, but I want you to make sure to have your calculator set to degrees. So if you have a Texas calculator, or I'm not sure if this applies to any other calculator, make sure to go to mode and then set your calculator to degrees. Yeah, so make sure to take a screenshot of this, take a picture of it, write it down, because this is a really important formula to know. And so here is an example I took straight from the combo quiz. It is number 21, and it states, what is the area of an octagon with side length of 6? So make sure to use the formula I just gave you, and you should be good to go. Make sure to pause this video so you have enough time to solve, but I will be going over the steps on how to solve afterwards, so make sure to press play in 3, 2, 1. So the first line shows n times s squared over 4 times tangent, and then parentheses open again, n minus 2, parentheses close, times 180 degrees over 2n, parentheses close. And then we're going to apply our knowledge, and so we know that an octagon has 8 sides, and so n equals 8 in the equation, and the side length, aka s, will be 6 now. And so the equation is now 8 times 6 squared over 4 times tangent, parentheses open again, 8 minus 2, parentheses close, times 180 degrees over 2 times 8, parentheses close. And then you simplify, which is 8 times 36 over 4 times tangent, times, parentheses open, 6 times 180 degrees over 16, parentheses close, which is simplified again to 8 times 9 times tangent, parentheses open, 1080 degrees over 16, parentheses close, which is 72 times tangent, parentheses open, 67.5 degrees, parentheses close, equals 173.823, which is the same as 72 plus 72 square root of 2. And there you have it, folks. Thank you for listening, and good luck.